Okay, students, I'm going to go ahead and work through most of this worksheet. These problems on here are very similar to the ones that you'll see on your homework assignment, so you can use this. Triangle midsegment theorem. This is almost the same thing as the trapezoid angle theorem, if you want to think of it that. The trapezoid midsegment, remember we just did that this past week here. And the difference is in a trapezoid, remember we had our two bases and our midpoint of each one that was connected, so that equaled that, and that distance equaled that. And we added the two bases together and divided by 2, and it gave us our midsegment length. Well, this is the exact same thing, but just think about this. The top one here, that length is 0, isn't it? So really, you're just taking half of this base, because this base plus 0 is still the base. This, in the trapezoid, we actually had two bases that had lengths to it. This top one, just think of it as 0. Otherwise, it's the same thing. You see the midsegment here, so D is the midsegment, E is the midsegment here, and again, it's going to be parallel to the, in this case, only one base, because point B is not a base, it's just a point. So if you want to call it a base, it's a base of 0. Okay, if you want to think of it that way. And otherwise, it's the same thing as the trapezoid midsegment theorem. Okay, so it says, use the triangle midsegment theorem to name the parts of the figure for exercise 1 through 5. A midsegment of ABC, triangle ABC. The midsegment is therefore segment DE, or you must have the segment symbol above it. Without the segment symbol, it means the distance from D to E. A segment parallel to AC. Remember, the midsegment is parallel to AC, so it's also segment DE. A segment that has the same length as BD. Well, here's BD. The other segment is segment AD. You got to make sure you have your segment. So segment half the length of AC. That is our mid-segment itself, segment DE. Remember, it's always going to be half of AC because the top base is 0. Let's see. Last one, a segment that has twice the length of EC. Twice the length of it would be BC, the whole side there. Okay. All right, down here now, use the midpoint formula to find the coordinates of G. Well, remember the midpoint formula is we've already dealt with this, x sub 1 plus x sub 2 divided by 2, which is the average of the x's, comma, average of the y's. That's it. So there's your midpoint formula. So write that down. To find the coordinates of G. Well, in this case, G is really easy because it's a vertical segment. So the distance from 0 to 4 is 4. Half of that is 2. And the x coordinate remains the same. So it's 0, 2. Okay, so I really didn't even have to use a mid segment. Now on H, again, this comes right at a corner. So I can actually just name that point right there, 3, 2. Okay. But it may not be that easy. That's why they're saying use the midpoint formula. It may come out to be fractions. Okay, these have been real nice right at the corners. But you need to remember, I can always find the answer by using the midpoint formula. All right, use the slope formula to find the slope of segment DF. DF, D to F right here, that segment. Okay, we know you should know from Algebra 1, all horizontal lines or segments have a slope of 0. So M equals 0. Remember, M stands for slope. Slope formula to find GH. Slope of GH. GH again is horizontal, so the slope is 0. Okay. If two segments have the same slope, then the segments are parallel. So are D segment DF and GH parallel? Yes. Okay, so we've already told you that in the mid-segment theorem for a trapezoid, you knew that the mid-segment was parallel to both bases. And now you're just showing right here, this is proving that the mid-segment is parallel to the base. Remember, there's only one base in a triangle. Okay, so we just proved that by showing they have the same slope. So remember, and you remember, anytime you talk about same slope, parallel lines, you want to think same slope. Versus perpendicular lines, you want to think negative reciprocal. You'll be using that later as well in another unit. Use a distance formula to find DF, the length from D to F. Okay, D to F, since it's a horizontal segment, we can just count that, and that's just 6. Okay, now you should be able to remember another name for the distance formula. I've asked you this multiple times. You should already have said it in your head. PT, Pythagorean theorem. Okay, so you can either, in this case, you don't have to because obviously it's horizontal, or if it was dealing with DE vertical, you just count. But any oblique segment, such as E to F, we would use Pythagorean theorem or distance formula. Of course, here it's graph, so naturally you'd want to use Pythagorean theorem. So, for example, if I was wanting to find D to F, E to F, okay, we know this distance is 4, this distance is 6, and we use Pythagorean theorem, we'd have 16 plus 36 equals EF quantity squared. That's like your C squared there. That's the side name of that side, segment EF. Well, distance E to F, so I don't need that. Squared. Okay, so that'd be 52 equals length from E to F squared. Take the square root of both sides, and 4 goes into 52 13 times. So then that reduces down to 2 root 13. That would be what EF itself was. The length from E to F would be 2 root 13. So that's an example of Pythagorean theorem. Again, we've already been using that. And the distance from G to H, well, that's easy to count. 1, 2, 3. Okay, so we didn't have to use that formula at all. Does the length of GH, remember GH without anything above it means the length or the distance from G to H, does the length from G to H equal 1/2 of the length of D to F, or distance from D to F? Yes, it does. Remember, we told you that's half the distance. So here we're just proving that, and that's how you prove it with distance formula. All right, use the triangle. Where's my recording? This better be recording. Yes, it still is. Okay. Use the triangle midsegment theorem and the figure to answer exercises 14 through 19. Remember, ST means the distance from S to T. Well, we know that is since we see that they're mid segments, because these are each half. S and T are the midpoints of those sides. So ST is a mid segment, so we know it's half the base. Since the base is 24, ST is 12, half of it. PU. Notice PU, U is a midpoint of PR, and S is a midpoint of PQ. So this also is a mid segment, and this is half of its base. Or its base would be, let me change the color here. The base of this one would be segment QR. So QR is double that length, since it says, let's see, so PU, it would be double that length. Let me get rid of all this so I can see everything here. Okay, so we do know that 11 is half of this base, so QR is 22. There's that question right there, QR 22. Okay. PU, we see that PR is a total of 24, so PU is half of that, because we see it's a midpoint, so half of 24 is 12. The measure of angle SUR, which is this angle right here. Remember, the middle letter is your vertex. So vertex is U, and then which side of U do we want, or the entire angle? We want SUR, so it's that right side right there. Okay, remember, these are parallel lines right here, because remember, it's not only half, the segment is half of it, it's also parallel. So parallel lines cut by a transversal. What did I tell you? The very first theorem you should be thinking of whenever you have parallel lines cut by transversal, you should be thinking AIA, alternate interior angles are equal or congruent. So that makes this 55. Well, then what do these two angles form? LP, which stands for linear pair, which means they're supplementary, which means they add to 180. So 180 minus 55 is 125. Okay. Measure of angle SUP. SUP, we already did that one. Just did it. 55 from alternate interior angles. And the measure of angle PRQ. PRQ. This angle, let me change the color. This angle right here is now what they're asking. Okay. Uh, let's see. PRQ. Okay, that one right there. All right. First off, we do know that it equals that angle, just so you know that, because we got parallel lines cut by a transversal. So those two angles are called corresponding angles. You got to remember that. So corresponding angles are congruent. This angle right here is congruent to this angle right here because those are corresponding angles. Okay. This was 125 right there. Okay. We also know that this angle is congruent to itself. 1, 2, 3, 4. Remember, that's congruent to itself. Reflexive property of congruence. Okay. Let's see. So PRQ. Where the heck? We don't have enough isosceles. Oh. So what do we have here? We just got done talking about parallelograms, right? So what we need to recognize is this is a parallelogram. How do we know that? We already know that's parallel to that. Okay, because that's the midsegment. So midsegment is half equal to parallel to its base. Well, don't forget, let me change that other blue to a black. This black, that's the midsegment of that one. So that means this is parallel to this. So now we have this blue-black triangle I have there, our parallelogram, quadrilateral is a parallelogram because the opposite sides are parallel, which means that's the definition of parallelogram. And what's the first thing you should be thinking besides the definition itself? And we know from parallelogram what are the characteristics. Opposite sides are congruent, which we don't need this because we're asking about angles, but we also know opposite angles are congruent. So since this is 55, this right here must be 55. Opposite angles are congruent. Don't forget what else is true. The diagonals bisect each other. Okay, in a parallelogram. Uh, let's see, what else do we have? The quadrilateral, we got, is that all? So I can't remember if I counted the definition as one of the four. Opposite sides parallel, opposite sides congruent, opposite angles congruent, diagonals bisect here. Those are four that I'm thinking. If I missed one, it's on the quadrilateral hierarchy. But what we need to know here is opposite angles. Okay. And that covers it. That should cover everything you need to know for your worksheet that you're doing. You're doing similar problems as this. Okay. So if you need to refer back to this video, that will do it. Where's the light here?